So I forgot to record this for the people that's not here. So where do we go to? We go to www.nc3search.com, right? And then it should come up and ask you for a username and a password. It do that. And what's your username is what? Your Lost Estate email address. And then the password is password1 with an uppercase P. Are we okay there? And then the first time you log on, applications that you're allowed to take as you signed up for. And we're going to what? Industry 4.0, Pesto Industry 4.0, and then we're going to click on Examine Details. I think I told y'all get 3 attempts, but you only actually get what? You only have to get 2. You get 2 attempts at passing. And then what we're going to do is you're going to go to View Curriculum. Don't hit Tech Test. Hit View Curriculum. And what this is, it's just going to bring a flashcard that you, of all the PowerPoints that I'm fixing to go through. Okay? Okay. We're here. Right this. So the name of this is Industry 4.0, which is basically what we're talking about is we're Industrial Revolution. I know y'all all studied Industrial Revolution in high school, and what we've actually divided it up to into 4 unique segments for what we're in. So right now we're in what we refer to as Industry 4.0, and that's what this covers. Everybody okay? This course is designed to teach students how to follow along with the instructor while he delivers the guides you through the steps as a class using PowerPoint presentation. Students pairs, so I can't remember about the pairs in here, but what we're going to do is we got little assignments that we'll do during the lecture, of course, to help break things up. It says you're not allowed to use electronic copies, but you are allowed to use the what? The flipbook. Well, basically what that means is when you're taking the exam, if you got 2 computers, you could literally what? Have the flipbook up. I think. Outline concepts of Industry 4.0, history of Industry 4.0. Actually, it's actually the history of all the different versions of what actually happened, what unique invention or what that actually split up the different sections of the industry. The basic terminology used in 4.0, and I know it's been a long time since I took the test, but there's a lot of terminology on that as far as that goes. But there is, if I remember right, we do have the ability to, and this might be something that you want to do. The first little link up there, was that available in y'all's? See if I can figure out how to get out of this. So do y'all have this Industry 4.0 terms? No slide. Okay. So what I'll do is I'll run these off and give them to you, because basically it's got all the terms in there. And that when you start taking these tests, it's kind of hard to memorize these terms. Where's all the guest on people? Y'all guest on people? They're not here. I'll run these off. So there's a lot of terms on the test: implications, benefits, and values of digitalization. And then some case studies applying to the concept of Industry 4.0. So at the conclusion, we should be able to explain the concepts of 4.0, understand how these changes impact the industry, current and future employees, and manufacturing process as a whole. Understand the benefits and values of 4.0, understand the concept of an interconnected world, understand the important terms, ideas, and concepts surrounding Industry 4.0. What you want to do now is you need to bring up Google or go to a different tab, and then just look for Industry 4.0. And then on a piece of paper, just write down some things that you learn off that site. We'll give you all about 10 minutes to do that. Basically, it's primarily automation and then just communication, right, between them. The term Industry 4.0 originated from a project in high-tech strategy in German government. By the way, we can look at these, we can look at all these links, but every one of these will just take you to the site for the German government and computerization, and then also the Hanover Fair. The term Industry 4.0 was revived in 2011 at the Hanover Fair. This is over in Hanover, Germany. They hold it every year. It's basically an industrial type fair, but they have well over 2,000 companies represented. A few 100,000 people come through this thing. In October 2012, the work group on Industry 4.0 presented a set of Industry 4.0 implementation recommendations to the German federal government. The Industry 4.0 work group members are recognized as the founding father of the driving force behind Industry 4.0. And of course, you know, this is a big company called Festo. Have you ever heard of Festo? Yeah, if you've seen any fluid power stuff and control stuff, Festo is they're one of the most widely recognized control systems, especially fluid power like pneumatics and hydraulics. So what is Industry 4.0? Good gracious, it's a conglomeration of stuff all over the place, right? Well, that will break down here on into our slide presentation. They'll break all this down into individual parts. So this said 19 million. So you can tell how far back this was. I need to reprise this. We had over 480 million results when we searched for Industry 4.0, right? So there's a lot of, often referred to as cyber physical systems. Somebody brought that up. This is considered to be the fourth industrial revolution. Smart systems are focused, not individual silo technology. What's silo technology? Silo technology. So basically, this is the definition we get for silo technology in business management, information technology. A silo describes any management system that is unable to operate with other systems, right? You understand that? So silo basically means stand alone. It's not connected or network to anything. And we still have a bunch of those out there, right? You understand? Where they're not connected. Focus, and they use it. And if they use a term in here that we don't understand, then we probably need to go back and look it up, right? So everybody can look that up. So focuses on synergies. Shall we look up synergies and see exactly what that is? So just type it into your bar and see what synergy is. So what does it say? Anybody got it? of a combined effect. So silo means what? Individual, and then synergy means it's a combined effect. A vertical and horizontal networking, top to bottom, left to right, and top to bottom, right? From the management all the way down to the workers, and the workers are talking together. First fact, so these are the different, this is on the test, what actually developed Industry 1.0 and 4 of that. So originally, when we were out there, or way back, everything was done by people, right? You understand that? So then it's animals, or we did it by wind, like sailboats and stuff like that, right? And then also by water. We had grist mills and stuff like that was wound around. This is not considered to be a major advancement in energy. This would probably be called Industry 0. What actually started Industry 4.0 was, Industry 1 was the first industrial revolution was the invention of the what? Yeah, the steam engine. It was originally invented in 1775, but the problem is this right here is only about 5% efficient. So that means it would take 105 horsepower worth of work to get 5 horsepower worth of work out of it. Very inefficient. What really happened is James Watt, and he's one of these guys that was fundamental in physics, and he got his name. His name actually stands for power, the rate of doing work. So if you ever look at your power bill, you're paid for so many watts of power, right? And of course, in your program here, you'll learn how to calculate power. But this happened in 1764 when he designed a thermal balance basic design. Basically what it did, it increased the efficiency of the steam engine. So up until then, most of your work was either done by people or some type of animal. Of course, the big thing back then was horses. Horses did a lot of work, right? And this is where the term horsepower came from. So work is, by the way, is force over distance. So what they did is they wanted to compare what work the steam engine did, because people understood horsepower, right? They understood how much basic work a horse could do. And they just got a bunch of horses and had them pull away. I think it was like 550 pounds over a certain distance. And then they timed them. And then they came up with an average. And then they hooked the steam engine up there and saw how fast it could move that same weight over the certain distance. And this is where the term horsepower came up with. So over here, when we talk about how much work an electric motor can do, we rate it in horsepower, right? You understand that? So that's where the term came from. So the steam engine brought out a different way of doing things. You could do them without animals, right? You understand that? And also it took a bunch of work away from people now. So it was actually patented in 1769. And there's the patent number. So the steam engine referred to as, it's a milestone, right? It led to what? The first automobiles were what? Steam powered. Locomotives were originally steam powered, right? You understand that? They came up with people digging with shovels. The first steam shovel, they were called steam shovels for that reason, because they ran that thing off of water, steam. So steam was the first, and this really changed the way we made things, right, or produced things. Threshing machines. Threshing machines is where you, what's threshing? You might know what that is. Threshing is when you separate things. So, like you've got wheat. Wheat comes on the end of a plant, right? You understand? And then the act of separating the wheat from the plant would be threshing. Used to, they'd just throw them up in the air and they'd stomp them and throw them up in the air. And now, of course, most of your threshing is done automatically. You get these big old combines that go out there and do what? They'll just plow up a field of tomatoes, and it spits the what? The plant out one side and the tomatoes out and it comes around down the conveyor belt. So this is just a picture of a common Newcomb's steam engine. If you can understand that, that's great. Industry 2.0. What arrived for Industry 2.0? Electricity. And that's an interesting story in itself. So we had two big companies. We had Edison and then Westinghouse, or two trying to develop electricity. Anybody know the two types they were trying to develop? AC and DC, right? And Edison was shooting for DC, and Westinghouse was shooting for what? AC. So this was when the first useful electric motor was designed in 1834. Useful electric motor. They fooled around with it. But we come up with things and they're very inefficient, right? You understand on how they convert energy from one form to the other. Operation costs 25 times higher than steam. Because here we're running off electricity instead of water. Ernest Winter von Siemens. So this was the guy that first came up with the company. We had a big company named what? International company called what? Siemens. So he invented something called the dynamo in 1836, and we were over there, and when we was over in Berlin, they had a museum over there, and they had the actual the dynamo that this guy invented, which was really cool. So the electric motor, major invention, right? You understand that? And then of course this is then what followed is production. So number two. The major invention that changed that led to the second industrial revolution was basically electricity. Are we okay? So second element was the Ford production line developed by Henry Ford. Henry Ford, accompanied by Frederick Taylor, developed 4 elements they believed would create an affordable mass-produced automobile. Taylor later became known as the father of scientific management. So what did Ford introduce? What did he introduce? Huh? The automobile was already here. He invented the production line, where instead of them coming in and bringing in one car and building that thing from start to finish, we do it in parts now, right? You understand? And each group has a different section. Scaling effect. So these are the 4 basic ideas that Ford and Taylor came up with. Scaling effects and their consistent implementation. Division of labor. Divide the labor up. So instead of bringing somebody in there and every one of them had to know everything about building a car, right? You understand? What did? They divided it up, and then you become specialized. Now they're starting to get away from that a little bit. I don't know if they do that at Rose or not, but what they usually do is they'll put you now on a section for a while, and then what do? They move you. And why is that? Because they found out over time people get complacent. They'll get so used to doing something, they don't do it, and they think they did. But if you keep rotating around and they keep you there for a while, then you're more alert to what you're doing. Introduction of automation. So they had actually a line that they'd set the chassis on, and it would actually do what? Move through the plant. And then they'd have the groups of people at each station doing what they needed to do. Creation of a market. And this is the first Model T Ford sold for $300. And I forgot how much less this was. So what happened is $300 then was a lot of money, but it was affordable for almost anybody. So now just about anybody could buy a car. First organization of automation. So this is just a picture of the Ford manufacturing plant, making Model Ts and whatever. I think they made several models on the same. Industry 3.0. This is when we started adding computers to the automation. When I first started working at US Steel, we had a lot of automation, but everything was done by relays. We did what we call relay logic. And you can do logic with relays, ands, ors, nands, nots, nors, that kind of stuff. And you did it all with relays. And we had one of our main automated systems was a system that actually put the zinc coating on a strip of tin. And when we first started there, they actually made the zinc coated roofing that they call it galvanizing, by the way. It's usually taking steel and coating it with zinc, because zinc is a very slow rusting metal. And it was all relay logic. And we had relay houses that was probably about where I'm sitting at to that wall, and it was probably about 15 feet wide. It was just nothing packed with relays, and then a couple of drives for DC motors. And then we got when they built number 8 blast furnace, they replaced just about all the relays with a couple of digital computers. They had 2 of them, and they were mirroring each other. So if one of them failed, they could do what? They could switch over to the other, and you want to do that when you're making hot metal, right? But that reduced the number of metal, but it had these big old tape drives on them. I don't know if y'all seen some of the old movies where the mass storage device where we stored our program at before we put it into memory with these big old tapes. In fact, the first computer that I ever got, we stored those computers on cassette tapes. We'd take a regular cassette recorder and hook the microphone jack up to the computer, and it would send out the buzzes out there to actually save it on the tape. And all the programs were stored sequentially, so you had to write the counter number down for where your programs were, so you know how to fast forward and reverse on your tape to connect to these programs. Milestone, Industry 3.0, the first numerical controlled milling machine. A milling machine is basically a machine that cuts grooves. So it cuts grooves in metal, and they use it a lot to trim the side of the metal and shape metal. So a router, anybody's got a router? A router is a lot like what a milling machine actually does. What do we do with routers? We cut patterns and stuff into wood, and that's basically what a milling machine is. These first guys used paper tape. I remember the first one I've seen. We called it paper tape, but after a while, paper would tear. But it was just a tape that we would set down on a keyboard, looked like a typewriter, and it would punch a tape. If I can find my marker. Here we go. There it is. And it was about probably 1.5 inches wide. And then it would just have holes punched in it. And there was 8 holes across because we were dealing with 8-bit, what we call 8-bit computers. And then it had an optical reader that would read it, and this is the way the programs ran, and the milling machine would follow that route. And originally it was paper, and of course what would happen every once in a while, people would tear it, and you'd try to tape it back together and punch your holes back in there. Originally they went to a Mylar type tape, which is a plastic tape. And you had big old spools that you would have, you'd run it through there, and the milling machine would follow that program up there. And that's basically the way the first supposedly programmable, it was a programmable, what they call it when the stitches close together, loom. It was a programmable loom that ran off paper tape. And all it did was just showed how far to go with stuff like that. Look at the computer on this thing though, if they show it. See this? So it took all that to run that one milling machine. So when we first started work here, the mainframe they had was an IBM 360. And it was in a big old room. It had all these flashing lights that looked cool. Used big old disk drives that were about 8 platters, and they set about this high. They don't tell me how much those things cost. In fact, if you're ever up in 210, that big old magnet I use up there to demonstrate how we create electricity magnetically, it came off of one of those disk drives. So it was a board. So it's pretty neat. So now we've gone to distributed computing, and we still have mainframes, but basically we use multiple computers on a network to share responsibilities, right? Industry 3.0, first robot used at General Motors. It was a Unimax. And this was this looks like a welding robot. The first robot they actually used was what we call a machine tending robot. It actually just moved parts from machine to machine. So that's basically what this FANUC robot back on the Amtro line does. It's a machine tending robot, and all it does is just move between them. We'll go back and look at that in a minute, by the way. So first industrial robots. What do robots do? Well, robots are basically just manipulators, but they are programmable, so you can change what they do, and basically they just move things around. I mean, but they do it really, really precisely, and they don't care. They don't care. They can work 24 hours a day. They don't need bathroom breaks. They don't need lunch breaks. They don't care if it's hot. They don't care if it's cold. They don't care. They just run programs. So Industry 3.0, this is where we started getting rid of these, which were just regular computers, guys. These were just regular computers. You might walk into a business somewhere and you'd see this computer sitting up there. And what they did is they just redesigned it and used the inputs to control this, but it was a standard computer. Of course, standard computers were not made to run in industry, right? You understand. So all these guys these computers had to be in air-conditioned houses. The people that worked at US Steel loved it, especially if they worked up there in the control house for the blast furnace, because it was all air-conditioned. Just about all the jobs outside was, hot. But these had to be taken care of. Programmable control. So what these were computers that were adapted to run machines. They weren't designed to run machines. They were adapted to run machines. Okay. A programmable controller is an industry-grade computer that's designed to run machines. So they're very rugged, right? You still have to take care of them. You can't play softball with them. But they're very rugged, and they're designed to run machines. And they program in a language that most electricians understand. We call it ladder logic. So PLCs, that's the main way we program them, even though we do have several ways. So first programmable logic controller used at General Motors, 1970 onward, 2D CAD system. So originally when you had, what does CAD stand for, anybody know? Computer aided design. Originally they were 2D. They didn't do any 3D at all. So it was a lot like people used to do on paper anyway. So all your drawings on paper was drawn in 2D. Originally though, we added 3-dimensional drawings to this, or what we call 3D CAD, but originally it was 2D. Done on a regular black and white screen. You should have seen it. And it was running under, I think these were originally running under Microsoft DOS. And just to change the orientation would take a long time. So these computers, they were fast at the time, but now they're really, really slow. Volkswagen launched the HAL 54. This is Automated Computer Integrated Manufacturing System, SIEM. First 3D was available, and now we could actually draw the parts on our computer screen and roll them around. And really neat now, just about all your drawing like AutoCAD, you can take a part and do what? You can rotate that around any way you want to. Of course, 3D is really, really popular in gaming now. First driverless transport system in Germany. So this is, we think driverless cars were invented now, but they were actually started in 1988, right? Understand that? And we're just now moving into that. Parallel to technical development, Toyota production lines. Now these phrases, and I might pronounce them wrong, but these right here, these were originally developed in Japan, and these guys are on the test. So Kaizen, what's that? Continuous improvement. Mura is the term used for waste, right? Mura, an imbalance, right? Mura, overload in jet, which is just-in-time manufacturing, which is just about what all your major manufacturers do now. So that way, if they get a bad part in and they don't have it on stock for 3 years, then it's up to the manufacturer of the part to make the correction and not them, right? So just about everybody does that. So are we okay? We're okay? So what was industry? What was before Industry 1.0? This is where we did everything either manually or with horses or wind, right? Or what? Or what? Water did a lot of work for us. And in Industry 1.0, what happened? I mean, 1.0, what happened there? Yeah, this is a steam engine, right? That brought about a lot of stuff. Used to it would take years to go across the United States because everybody did it with horses and covered wagons and stuff like that, right? And then when they came up with the steam engine, they started laying rails. And now instead of being weeks or years, it took what? Well, yeah. Now we make it in hours, right? Okay. Some things that happen in Industry 2.0. So what's 2.0? Electricity. Good gracious. Just brought up so many things, right? Even something as simple as going to electrical lighting and not instead of gas lighting. You know, I was doing some reading and they was talking about uh, sometimes they had gas lamps all over these cities. And sometimes the light would go off and it would be just sitting there doing what? Filling up with gas. And when somebody tried to light it, what would it do? It'd blow up. Yeah. So let's talk about the number of people that got hurt just by trying to relight gas lamps. Then it went out. Electricity added lighting, it added electrical motors, right? You understand that, which is really, eventually it actually added relays. Y'all know what a relay is? What's a relay? So what do I do with a light switch? We turn things on and we turn things off, but it takes a human being to do that. A relay is an electrically controlled switch. So instead of a human trying to change the positions of the switch, we use electricity to change position. Which basically now we can automate it, right? Because we're going from physical or manual over to being able to do it manually. And electrically. And we'll show y'all some relays back on the manufacturing. Industry 3.0, this is when we added a specialized computer that's designed to run machines. And computers are what we call programmable devices. So up until then, up until PLCs, when they made cars, they very seldom, when they changed cars from year to year, there was almost no change made at all, very little changes, right? Because everything was done either manually or understand it, very, very little automation. So originally what they do is they'd have two production lines because everything had to be hardwired, everything had to be manually hardwired or installed. So if they wanted to change the shape of something, they'd have to use a different die, right? You understand that? So what they did is they ran two manufacturing lines. One of them was being reworked for next year models while they was making models on this year because everything was hardwired. When they came out with programmable things, it means now we could do what? We could change the program instead of going out and changing a bunch of stuff on the line. Now they still have to do that every once in a while, right? You understand? But when even making the frame, instead of bending it at 90 degrees, I might could change my program to bend it at 45 and make a different thing, right? You understand? So now, like when Mercedes goes between their models, they're like down for three weeks to change over to the new model with, because everything is programmable, right? All the robots are programmable. So instead of changing this, they just change the program, and there's basically very little mechanical stuff they have to change. And what I understand, they scrap the first 300 cars. And what they're doing, what they scrap, they do is they put them together, and then they do what? They take them all back apart to make sure they were put together right. And then after that, that's when they start producing. So programmable controllers. This really, really, really changed things. Programmable controllers with something referred to as sensors. What is a sensor? there, that was one of the actual robots that did the frame level. So physical megatrends, what we call flexible manufacturing, right? You understand, uses lean manufacturing, which means doing it as cheaply as you can, the best you can do it, right? You understand that? In fact, we teach a course here on safety and lean. I think some of y'all might be in it. And then digital megatrends, big data. We're talking about big data. You know, binary information takes up a lot of, so digital, not binary. So computers deal with a number system that we call binary, which is nothing but ones and zeros, guys. This would equal to a number 10. Okay. And this would be the 10 itself. 5 in binary would be this. In decimal, it would be that. 60. Information, it takes a lot of space because what we're trying to do is we're trying to represent numbers with digits that only has 2 combinations. So binary is easy to represent because all we're dealing with is ones and zeros. And we can very easily represent ones and zeros with different quantities, right? You understand? The light is there or the light is not there, or the voltage is there or the voltage is not there. It's really, we can send it over great distances with little error because all we're trying to do, and the analogy I use would be like somebody having a flashlight up on the hill over there and has a switch on it that goes through 10 combinations of brightness. And you're down here trying to discern or to figure out what number they're trying to send you. And how far can that person get off, and can you tell if the light is on or off? If you can see them, you can tell that. And that's the big advantage of binary. We can send it over great distances with very little loss, right? You understand? And the other thing is processing the information, doing math with it. Math circuits in binary are extremely easy. Math circuits on decimal is very complex. And plus, binary computers can make things appear like they're not really are. So what you're looking at up here, you're looking up a bunch of dots. And they either turn the dots on or they turn the dots off, and we see images, right? It does it in 4 colors. Anybody know the 4 colors? Red, green, blue, and black. So we have 3 colored dots on the black background. And then we can blend those together, and how many colors can we see? We can see all the colors. A lot of people don't understand, but that's the 4 colors that your eyes see. You only see 4 colors. You see red, green, right? Red, and then you see shades of gray, which is what? Is black. So, but we have to, it takes a lot of space to control this thing. And we start talking about the memory in a machine. This machine has 8 gigabytes worth of memory. Forward. We'll see if this video works.